Well, hello, good evening, and welcome everybody to this first Q&A of the autumn season of the Geography for Schools lecture series here at Royal Holloway. And tonight I'm absolutely delighted to be joined by Simon Armitage, Professor Simon Armitage from the Department of Geography, who spoke brilliantly last week on the issue of sand dunes. And there's lots of questions that I have stored up here for you, Simon. Simon, your work sits at the interface of archaeology, geography, and environmental science, and is really at the cutting edge. And I do want to ask you more about your career and how you got into this topic as we go on. But I think one of the things that I think people would really benefit from is just hearing maybe a 2 or 3 minute summary of what you spoke about last week, perhaps for those people who didn't hear it or who are still to tune in. So in the first instance in this session, let me hand over to you, Simon, so you can just reprise what you were talking about last week.
Okay, thank you very much, Alasdair. So the title of my talk was The Formation of Dunes in Hot Deserts. So essentially, I wanted to think about how you got dunes in the first place, so where all the sand came from, and then also to think a little bit about the factors which cause different dunes in different places to be different shapes, and what that can tell you about the environment that they exist in. But actually, the first thing I did in the lecture was to make the point that not all deserts are full of sand dunes. So actually, quite a lot of the world's deserts are rocky, and quite large parts of deserts that have significant numbers of sand dunes are rocky. So it's worth pointing out that sand dunes are not the only landscape component that you have within a hot desert. So the first thing you've got to do to produce a sand dune is to have sand in the first place. And paradoxically, almost always sand is produced by the action of water. And obviously we don't think about hot deserts as being particularly wet places. But there are two answers to that. Quite a lot of the world's deserts have been considerably wetter than they are in the present day. So very often you've had lakes, rivers flowing in those areas, and they've produced the sand that subsequently gets turned into sand dunes once the desert dries out. It's also quite often the case that rivers that start outside a desert or flow through a desert area produce quite a lot of sand, and therefore it's parts of the desert that are, or sorry, parts of the landscape that are outside of the desert itself that are producing the sand that subsequently gets turned into sand dunes. And in the lecture, I gave a couple of examples of that. The first is the Namib Sand Sea, which is a truly spectacular collection of linear dunes on the coast of Namibia in southern Africa. And essentially the sand for that dune field is produced by the Orange River. So the Orange River drains most of central southern Africa, and it drains into the Atlantic, and it takes an awful lot of sand and sediment with it. And then that sand and sediment gets moved up the coast by the Benguela Current, and over time, coastal processes bring that sand back on shore, and so the sand comes back on shore, and it gets progressively moved northwards by winds that run along that coastline. And so essentially, the Namib dunes that we see in the hyper-arid Namib Desert are actually a result of sediment transport and sediment creation by the Orange River. And the interesting thing about that particular sand sea is that it's also terminated by a river. So right at the northern end of the Namib Sand Sea, there's the Quiseb River, and that floods annually, and essentially it just cuts the end off each of the dunes that have migrated into the riverbed, flushes all of that sand back out into the Atlantic again. And so actually we can think about the Namib Sand Sea as just being one part of a massive sediment conveyor belt that moves sand from the central southern African continent into the Atlantic, back out of the Atlantic again into the Namib Sand Sea, and then back into the Atlantic once more once the end of that sand sea is terminated by the Quiseb River. So there are lots of ways in which water can deposit sand within a dryland, but once it's happened, the shape of the dune that you get is dependent on a number of factors. The first two, and the two that we classically think about, are sediment supply status, so how much sand there is, and also wind variability. Does the wind blow from one direction all the time, two directions over the course of the year, or multiple directions? But that can also be affected by vegetation, which tends to anchor sand dunes and therefore stop them migrating, but also topography, so essentially the elevation of the landscape, which tends to both focus where sand moves within a particular landscape, but also provide relatively sheltered areas where sand can accumulate and form into large sand seas. So I ended the lecture thinking a little bit about the different shapes of dunes that you get under different circumstances. So if you have wind blowing from one direction all year round, you get one of three different types of dunes. You either get bark end dunes, which are individual, relatively small solitary dunes, if you have a limited amount of sediment supply. If you've got a bit more sand in the landscape, then those dunes will tend to merge together to form barkanoid ridges. And if you've got a lot of sand in the landscape, then you will end up with transverse dunes, which are effectively large waves, very like a seascape that you get in the landscape. If, on the other hand, you have two different wind directions, so what's referred to as a bimodal wind regime, then that tends to form dunes into linear dunes, which are long dunes running downwind, essentially, whatever the resultant sediment transport direction is from those two different wind directions. If, on the other hand, you have a number of different winds, so relatively complex wind regime over the course of the year, you essentially get big piles of sand, which very often look like kind of starfish, and they're referred to as star dunes. So that's a brief summary of my lecture, Alasdair.
Simon, thank you very much. That's been a very helpful summary, I'm sure, for everybody, including myself. I have to say, Simon, I know, and I can see on the map and behind you that you're passionate about arid areas, about desert areas. You spend a lot of time in that part of the world as well. And I think one of the things that I would like to ask you, because I don't think we've really spoken about this before, is how you in fact got into this particular area of geographical research. What is it about these hot parts of the world that first kind of drew your attention towards them?
As is so often the case, it was a brilliant teacher. Actually, it was a brilliant lecturer called Stephen Stokes, who taught me when I was an undergraduate. And he had spent a lot of time trying to understand the way the Sahara, particularly the Egyptian Sahara, had got wetter and drier over time, and what that tells us about climate and people and things like that. And I went off and did my PhD on something completely different, but he then employed me again to come back and work with him and to look at the amount of dust that was being blown out of the Sahara into the Atlantic Ocean. And from there, to be honest, it was a relatively straightforward hop to actually move on land and start actually going to various African drylands and try and understand what the landforms in those environments could tell us about past climate, what it could tell us about, human mobility, ancient human societies, all that kind of stuff. And I was just absolutely captivated by the landscape. So I first worked in Tunisia and then southern Libya, and these are just beautiful, stark, very barren landscapes, but places that are just incredibly enjoyable to be in and experience. There's a whole lot of nothing in large chunks of the Sahara, and I really enjoyed that experience.
I mean, as you know, I'm a geopolitical scholar, and I mean, deserts and arid environments are really fascinating for political geographers as well. And as you also know, I work on no man's lands, and so often parts of the world that are desertified have been referred to as no man's land because there's a perception that they're devoid of human life. And I know this is slightly moving us away from the topic at hand, but of course, one of the things about the Sahara is that even though it's a very harsh environment, it's certainly not devoid of human life and human existence at all, either today or in the past. And
Yes,
I know
that's
that your
certainly
work
true.
has looked at, for example, the way that the Sahara has sustained life at key moments and has been a site of important mobility as well for human populations.
Absolutely, and that's true on a number of different timescales. So we as human beings, we're an African species. We appear to probably be a southern African species. And one of the big conundrums has always been, how did our ancestors go from southern Africa and kind of move through the Sahara Desert and become the global species that we are today? And the answer seems to be that both the Sahara Desert, but also the Arabian Desert, which is equally important in terms of understanding that out of Africa migration, they get considerably wetter and considerably drier over time. And what appears to be going on is when the Sahara and Arabian Peninsula become wetter, that simply allows people or populations to expand into those regions. They probably don't think about it as leaving Africa. It's just they're occupying space that's there and available for them. But that seems to be how our species gets into Asia, and from there, of course, it gets into Europe and the rest of the world. And it all seems to be due to the dynamics of the Sahara and the Arabian Peninsula. And actually, even over quite short timescales, if you think about the Sahara as certainly the world's largest hyper-arid desert, it was a lot wetter, contained a number of very large lakes as recently as 7,000 or 8,000 years ago. And if you go to the Sahara, the place is absolutely littered with archaeology of that kind of age, because people are simply living in that kind of landscape as they do in much wetter landscapes in the present day. And so the Sahara has been a site supporting human life for a long time.
That's really fascinating. And in fact, that leads me perfectly onto the next question that I had, which was related to this point that you made about the relationship between sand and water. And in desert environments, of course, one of the definitions of a desert environment is a lack of water. It's a lack of rainfall. I mean, that's kind of one of the key characteristics of a desert. So I just wondered, can you just tease out that relationship between sand and water for us a little bit more? But then I think importantly, what kind of archaeology do you use in order to try and reconstruct those past environments? So what is it that you see in the surface or subsurface or in the human archaeology that remains that tells you about those past lakes and watery environments from the past?
Well, that's two questions, isn't it, Alasdair?
It is a bit. I've smuggled in two there.
You certainly have.
That.
The answer to the first question is essentially, to generate sand, you've got to have something that grinds up and breaks up the rock. So that almost invariably is water. So if we think about a coastline, a sandy beach, that's the repetitive action of waves breaking up the rock. Exactly the same thing is going on in rivers as well. So essentially, it's the energy of water passing through a landscape that breaks up the underlying geology and produces sand-sized grains. And sometimes that's happened a very long time in the past. So actually, the ultimate source of quite a lot of the sand in parts of the Sahara is the sandstone that underlies the Sahara. But that, again, is the action of water just much, much further in the past. Your second question, I think, was about what aspects of the archaeological record can tell us something about climate change in deserts. At a fairly basic level in the Sahara, its mere presence or absence is a good start, because there are, certainly in the parts of Libya that I've worked in, really not very many people in the present day. And prior to mechanized transport, it was not a straightforward place to get to at all. Yeah. The archaeology that we see from 10 to 8 to 7,000 years ago is very often whatever survives when you've stripped away any soil that there was in the landscape, and anything that was made of perishable materials is gone. So we see rocks that have very clearly been shaped so that you can tie a stone around it. So you can tie a rope around it, so you can tie a rope around the stone. Then we assume that gets tied to the leg of a cow or a camel or whatever, and it hobbles it, it stops it moving about the place. Fireplaces you see all over the place. So very often people dug pits into the soil, lined it with rocks, lit a fire, that heats the rocks up. You can then use those rocks for cooking. Now, the only thing that's left after the Sahara has dried out is these mounds of very clearly burnt rocks, and they're very distinctive. You just see these black piles of rocks all over the place. And you see exactly the same thing in the Arabian Desert. In terms of looking for lakes, you can quite often see shorelines. So there are very often straight lines in a landscape that have no cause to be there if they weren't the shoreline of a lake. And actually, if you look, say, on Google Earth around Lake Chad, you see lots of, tens, hundreds of kilometre long lines in the landscape, lines in the sand actually primarily, and they're sandy shorelines that Lake Chad produced really not that long ago.
Gosh, so in fact, there's a whole series of different things that you can look for. I remember, you will remember too, Simon, that in 2015 I went on an expedition into no man's land to try and get to a place called Bertawil, which sits between the borders of southern Egypt and northern Sudan. And I remember you telling me at the time, keep your eyes open for these piles of black rocks, which could signify these ancient fireplaces, as you've just described it. And then that they say that sand is this excellent insulator, don't they? And so if you light a fire, the sand itself can become incredibly hot. And does that also produce any kind of solidified lumps of silica or anything like that, or are you just looking for black rocks? So are there anything else that gives away those ancient fireplaces?
Fireplaces don't get hot enough to melt the sand. That's one of the reasons that you can use sand to put out fires. Last year we did some experimental work looking at quite how hot the sand gets underneath fires, in this case in southern Africa, because we're interested in finding fires in an archaeological site that we work at. And they'll comfortably get to 500-600 degrees C, maybe up to 700 immediately underneath the fire. But even if you only go 10 centimeters underneath the fire, they probably don't get much higher than about 150 degrees C. So that's where the insulating properties of sand come in. It's extraordinary. One of the things you very often see associated with these fireplaces is, again, the non-perishable things associated with everyday life. Very often you see flat rocks with a smaller kind of hand-sized rock, and that's clearly been used to grind up grain. It's a very, very clear kind of small hand-portable millstone. You also very often see stone tools that people have produced, and because the soil's gone, it's not hidden under the soil, it's just sat there on the sand surface.
And these can survive for, we're talking thousands of years, just sitting on the surface of the desert floor.
Yeah, hundreds of thousands of years, and this actually is one of the problems. So you can get material that's, say, 500,000 years old, so well pre our species, next to something that was produced a mere 8,000 years old, and actually you can only really tell that one's much older than the other because it has to be, because it's a different shape, it's a different type of tool that we know different people were producing.
And that's literally the only way that you can do it, through that kind of identification, or are there other techniques that can help you out with that too?
You can look at the surface, and sometimes if it's literally been at the surface for a long time in a sandy environment, the older material will be progressively eroded away or polished by the action of sand over time. But that's a long, slow process, and quite often we think that things get buried a little bit, and that protects them from that. So yes, it is quite difficult to distinguish the truly old from the relatively young.
Gosh, okay, this is, I'm learning a lot here, Simon. So thank you for this information. Now, one of the activities that you've set as part of the teacher hub that we have is you've asked people to try and identify different shapes of dunes and to think about the relationship between wind and sand. So we've talked about water, so now we're going to talk a little bit more about wind. And you gave a really nice introduction to different wind directions, multiple wind directions, and the effect that they can have. Can I just push you a little bit further? I wish this is one of those moments where I wish you had a kind of chart of illustration, so you could show us the different sand dune formations. But you mentioned sand dune formation in areas of the world where wind is coming predominantly from one direction. Now, I had to confess, I didn't study sand dunes as an undergraduate. So could you just go back over that for me? You used a particular name of sand dunes that form in a predominantly kind of uniform wind direction, and I didn't quite pick it up from you.
Yes, so there's a continuum of sand dune types that you get depending on how much sediment you have when you've got wind blowing from one single direction. And when you have relatively little sediment, so if you've got a relatively flat plain, not very much sand in that landscape, you get a thing that's referred to as a bark dune, which is essentially horseshoe shaped.
Okay.
And if you think about the shape of a horseshoe, essentially it's got a rounded end and it's got two horns. Now, a barcan migrates horn first, so essentially it's being pushed downwind with the pointy bits going in the direction that the dune's going. And these, like all dunes, tend to have relatively shallow upwind faces and relatively steep downwind faces.
Okay.
So that's a classic solitary dune, and there are lots of those in the exercise, the classroom exercise that you should be able to find on Teacher Hub, because they're pretty, because they're very easy to identify, and because there are lots of them in Egypt where essentially that session is based. If you have a bit more sand in the landscape, but again, wind coming from one direction, those forms tend to merge together. So you've still got that horseshoe shape, but they tend to kind of form into wiggly lines of horseshoes, if that makes any sense. And so you can still see the bare desert floor between the dunes, but you haven't got individual barcan dunes anymore. Now, if you have a very ready supply of sand, actually that goes away as well, and you end up with a desert floor that is almost totally covered by sand, but then you just have waves which are running across the direction of the wind, and these are referred to as transverse dunes. And again, the upwind side is relatively shallow, the downwind side is relatively steep, but all of these smaller forms have kind of merged together into a sea of sand.
Okay. Transverse dunes, that is familiar from the past, even though I didn't study sand dunes. That's something that I've definitely heard of. Barcan dunes, however, is certainly new to me, but I've got it in my mind, and I think I'm pretty sure I must have seen those kind of formations when I was in Egypt as well. So no, that's been really helpful. And then you also mentioned, did you call them starfish dunes? did I pick that up right? Dunes. I think you rather unkindly called them just massive piles of sand,
Well,
and that's what they are.
Yeah, that's exactly what they are. So if you have a very variable wind regime, then essentially it tends to not move sand about in a particular direction, but it tends to pile it up. And I said not starfish dunes, I said they're shaped like starfish. So you've got multiple limbs kind of moving off in various different directions.
So this is not a formal name that people should be reproducing in their exams.
No, but star dune is. It's perfectly legitimate to call one of those a star dune. And the interesting things about star dunes is, and they're relatively rare. They exist in quite a lot of dune fields, but they're relatively rare. And very often you find them at the edge of dune fields as well. But they can become the largest dunes because you don't have a predominant wind direction. The whole thing isn't moving downwind. It's just accumulating sand over time. And so some star dunes get up to in the order of 500 meters high. That's unusual, but that's by far and away the largest dune form that you would find in a desert on Earth.
Right. Thank you for correcting me and for keeping me right. The last thing we want to do is for people to leave this session with a false understanding of star dunes, or indeed, as I shall now christen them, starfish dunes. Now, Simon, the last thing I wanted to ask you before we let you go and we let our viewers go is something that I had come across fairly recently, and it kind of relates, I guess, to COP26 and to the work of the UN and concerns about climate change in desert environments. I had come across reference to something called Africa's Great Green Wall. This is a proposal. A proposal that the UN are backing, and apparently $8 billion has been set aside to fund this scheme, but it's particularly around the Lake Chad area to effectively reintroduce vegetation into a desert environment in the hope of my reading was, and correct me if I'm wrong, of stopping kind of desert spread around that area by effectively reintroducing vegetation and effectively reestablishing perhaps a past ecosystem or something that has been lost. I know this isn't necessarily your specialist area, but I wanted this is something that students might very well have picked up on. Can you give us any more details about that scheme and maybe what they're trying to achieve there?
Yes, this is a very interesting idea. So as I understand it, what is trying to be achieved here is to re-establish a form of vegetation that would probably have been there in the past before humans interfered with the landscape. And that makes sense because vegetation is the thing that stops dunes moving about the place. So there are a couple of places in the lecture where I showed you some photographs of a landscape that used to have dunes in it, and they've now been vegetated, and that means that those dunes become fixed, and effectively it just becomes a rolling landscape. So if the vegetation of a region has been damaged by human use, it would be perfectly rational to try and put some of that vegetation back, presumably help establish it. But once it's there, it will tend to stop sand mobility, tend to stop sands moving around the place, and therefore re-establish itself as a buffer at the southern edge of the Sahara. Lake Chad's an interesting one because Lake Chad fluctuates in terms of its level, both in response to natural causes, but also in response to human causes. So on a very long time scale, you would expect Lake Chad to become very large, dry, become very large again, roughly every 21,000 years. So that's one of the Earth's orbital cycles. That's a precessional cycle. There'll be periods of that when Lake Chad is full because the Sahara is relatively wet, and periods where it's much less full because the Sahara is relatively dry. But the other thing that affects the lake levels in Lake Chad is human water use. So some of the water in Lake Chad comes from outside of the Sahara. It comes from quite a lot further south towards the Intertropical Convergence Zone in Central Africa. And obviously there are lots of places upstream where you can take water out of the various rivers that feed Lake Chad, and that of course will cause Lake Chad itself to lower in level. So there are two things that you'd need to do if you were trying to establish vegetation in this kind of region as a buffer against the desert. One would be to be sure that the landscape was capable of supporting that vegetation, because if it's dry and sandy because the landscape isn't capable of supporting vegetation, then anything you plant there is just going to die. If, on the other hand, there's enough rainfall, or you can afford to irrigate it for a period of time to establish the vegetation, then actually it will tend to reinforce itself, because one of the things that vegetation does is it puts moisture back into the atmosphere. That comes back down as rain again, and it begins to be a kind of self-fulfilling cycle. And actually, if you look at the effect of vegetation in quite a lot of climate models, it does tend to reduce drying effects that you would otherwise see. So if you've got a well-vegetated landscape and you force the model in some way that makes that landscape get drier, having vegetation in the landscape will tend to push back against that and keep the area moister for a period of time until eventually there's not enough moisture to support the vegetation, at which point, of course, it doesn't.
So this is actually a really interesting and ambitious project, and presumably they have had a whole host of ecologists and environmentalists work out, what this land could, in theory, sustain. But also, this seems to be a way of, it might require the kickstart of the introduction of water into this environment, but what you've just said is that might create a kind of virtuous cycle where the vegetation then ends up producing moisture again. So and presumably if it's reintroducing moisture and water and potentially lake environments in the future, this will also then lead to the production of sand.
Yes, I suppose it might. Though actually the Chad catchment itself is very sandy, and the reason for that is that it's a basin that doesn't primarily drain into the oceans. So any sand that gets produced in the Chad catchment tends to end up within the Chad basin. You have to get Lake Chad up to a much higher level than it is at the present day before it starts draining into the Niger River, at which point potentially some of that sediment could be lost to the Chad Basin. But actually, that's not going to happen anytime soon.
Okay. Simon, thank you very much. I rather put you on the spot there with that one, but you answered that brilliantly. And I think a lot of people will be really intrigued by that kind of project, and the fact that 8 billion has already been pledged to try and see that through. Although I think more money is clearly required, although it looks like some of the political will might be there. I'm going to stop sharing that screen. Simon, thank you very much. I think we're going to leave it there. But what I want to do now, while I have you there, is just to, first of all, say thank you for this and for the lecture. I also want to advertise what is coming up next Monday. So we have Professor Pete Adey, who on the 11th of October at 5 o'clock will be talking about air travel mobilities. Pete is a human geographer, a political geographer who specializes in global mobilities. So he'll be talking at that subject at 5 p.m. on the 11th of October. And looking slightly further ahead, we have 2 more talks. We've got Don Thompson talking on the 1st of November about catchment hydrology, and Phil Krang on the 15th of November talking about the world on a plate, culinary connections, globalization and changing places. So those are all coming up for your delight and delectation in weeks to come. And there will always be a Q&A with that person in the week immediately following. Simon, again, thank you very much. And to everybody at home, please do have a look at our Teacher Hub online on our university website, the Royal Holloway Geography website. And I'm going to put up a slide just to finish this talk that shows you where to go for more information. So in the meantime, thanks ever so much, and I will see you again for the next Q&A in 2 weeks' time. And next week, of course, it is Pete Adey on air mobilities. Simon, thank you once more.
It's been a pleasure.
All the best. Bye-bye.